Welcome to Ask and Learn.
We're asked to construct a deterministic finite-state automaton that recognizes the set of all bit strings that contain an odd number of zeros. So, the set of strings we're going to recognize is the set S, which can be represented as the set 0, and then the set 0, 0 star, so that we always have an odd number of zeros in the string. This is actually, instead of being 0, 0 star, this should be 0, 0, 1 star, because we can have ones. Now, let S0 be the start state. And in fact, this really isn't a good description of S, because we could also have bit strings that don't start with 0, which still have an odd number of zeros. So instead I'll just write this as the set of all bit strings with an odd number of zeros. Still, we're keeping S0 as the start state. Now consider the empty string. The empty string is not in our set S, so it follows that S0 is not a final state. And let's consider another state, S1. So we have that S0 represents that there were an even number of zeros in the previous digits. And we have that S1 represents there were an odd number of zeros in the previous bits. And therefore it follows that S1 is a final state. Now let's consider the transitions. So suppose that we're at S0 and the input is a 0. Then we're going to move from S0 to S1, since the total number of zeros increases by 1, and we had an even number of 4, so the total number is now an odd number of zeros. Likewise, suppose that the input is 0 at S1, then we're going to move from S1 to S0, because the total number of zeros at S1 was an odd number. Since we're adding one more, now the total number of zeros is an even number. And finally, suppose that the input is 1 at either state, then we're just going to remain at their current state, since the number of zeros doesn't change.